Hello everybody and welcome to this webinar series on IHE profiles related to FHIR. This is a webinar series organized by HL7 Finland and it is free to attend for everybody. And the profiles will be presented by John Moehrke. Can you please introduce yourself and the topic and take it away?
Sure. Thank you for inviting me. So I am John Moehrke within IHE. I am co-chair of the IT Infrastructure Technical Committee. I also participate in HL7, where I'm co-chair of the Security Work Group, member of the FMG, and part of the FHIR Core membership. So I participate in those two organizations a little bit within DICOM. What I'm going to be going through is kind of a family, if you will, of IHE profiles that support a document sharing based exchange, specifically focusing more on the newer models that use FHIR and the variations that are available. I am reusing presentations that the IT Infrastructure Committee maintains on the GitHub. So I have up on the screen, if you go to this particular GitHub, there is a presentations folder that has all of the presentations. So in this case, I'm reusing one that Gregario gave in June of 2023 to Dev Days. So I'm starting on page 2 or 3, depending. So if you need the slides are available. They're on GitHub, so we track them that way. If you want to look ahead at some other topics, the other slides are there. I might end up through some of the future presentations needing to create some new slide decks, but much of the material is already there. So just letting you know about how to get a hold of the slide decks. So I'm going to be going through, generally speaking, what document sharing is, rather short because I kind of expect that there is some understanding of that. I'm going to talk through FHIR methodologies of accessing document sharing, some of the support profiles that are needed for patient identity and authentication and authorizations, those kinds of things. I am going to go into a little bit about some potential ways to improve the usability of the documents through accessing via resources. And then I'll potentially touch upon a completely FHIR-based solution called MHDS. All right, so slide advance. So document sharing originally, almost 20 years ago was put together by IHE. It was based on W3C standards. One of the benefits that IHE has is that we can profile any standard. And in this case, we profiled a W3C EB registry standard that used SOAP, and the security model used SAML and TLS. We had at the time a patient identity cross-referencing, PICS, and a patient demographics query, PDQ, available that used HL7 V2. Ultimately, we did use an HL7 V3 model as available, but for the most part, the V2 is the surviving one from that perspective. XDS supports a centralized registry and distributed repository. So the repositories can be centralized. You can have one, but typically the repositories would be distributed, and I'll show that on the next slide. Security, we leveraged, IATF standards, TLS, SAML, those kinds of standards. There are some variations in security. This isn't, going deep into XDS, but there's variations as well. So this is displaying the high-level view of a document sharing exchange. In this case, it says XDS, but it's really the concept we have for, generally speaking, document sharing. There is some kind of patient identity manager. In this case, PICS or PDQ. In the case of MHD, we'll get into PICS-M and PDQ-M, and I'll explain those when we get there. It is centralized. There is one of those. And then there is these little silos around the outside that are the document repositories. Those would tend to be something that's implemented by the source organization. So the organization that is publishing a discharge summary would tend to hang on to the discharge summary itself and just register some metadata with this document registry. That document registry enables others to discover that this discharge summary is available and where is it. And then the XDS mechanism allows for someone who wants to use that discharge summary to retrieve it from that particular document repository. So in this way, many different kinds of data sources can be available on this exchange, and actually many different consumers. This is diagrammed as if everybody has their own document repository, which implies that everybody has documents to share. That may be the case, but it doesn't have to be the case. So, for example, maybe patients are really only participants as queries and retrievers and not publishers. It doesn't mean that patients couldn't publish. I'm just kind of using it as an example. So there are some principles of the document that were well established, a dozen years ago-ish. And these are predominantly understood as principles that CDA promulgated. The fact that a document has some persistence, it is there in that version, in its original form. It has an owner. It has the ability to prove that it is complete and that you didn't get a partial of it. There is context within it. Who is the patient? What is the setting? Who is the author? What is the medical condition that happened leading up to the discharge? And it has some form of readability, and lots of people argue there. But effectively, these principles of a document benefit the publisher. So the publisher can say, hey, I gave you something that had stewardship and authenticity. It had context. It was whole. If you didn't understand it, that's a you problem. So the principles of document are very helpful to publishers, and I'll come back to this topic in a little bit. With XDS, and obviously the MHD equivalents, we originally understood that it needs to be content agnostic. Although CDA was predominant at the time, we also had DICOM that wanted to be able to publish content. Many people were publishing content with PDF or text files, and now we have FHIR documents. So being content agnostic, yet content preserving, we magically supported FHIR documents right out of the gate. We didn't have to do anything because the model that we developed, this metadata model and the distributed model, immediately supported any future type of data, as well as any historic type of data. We defined some metadata to enable discoverability and the like. I'll get to that in the next page. Yes, we have some particular content specifications for things like CCDA or C32. We now have some publications that are utilizing the HL7 IPS. We have DICOM documents. We have PDF documents. All of them are available. And one of the special attributes of this model is that one particular content can have an association with it of other encodings of it. So this diagram on the right here is really showing that there is some primary content, and there is a PDF version of it, there's a CDA version of it, there's an image version of it, and there's FHIR documents version of it. It's the same content, just different encodings of it. So there's that model that's built into it as well. And then lastly, on this slide is that we have some special concepts. We have a delayed assembly concept, which means something like a discharge summary. If no one's ever going to want the discharge summary, I could record a discharge summary for this particular time frame and this particular encounter could be created, but it hasn't yet been created because we don't know if anybody wants it. So it could be delayed assembly. As soon as somebody asks for it, it gets assembled and it gets made available to that and anybody else. On demand is something that we use for things like document summaries. So an on demand simply says, hey, I'll put out this contract that says I will create a fresh medical summary. For example, I will create a fresh medical summary on demand. And in that case, when someone comes along and says, yes, I want that medical summary, that asking for it creates a fresh version of a medical summary. There's options within there to preserve that particular instance. So in case you want to go back to the instance you pulled, you can. And there's always with on demand, and any other ones can be created. So rather quickly, we have this metadata model. It's designed to support discoverability, but it's also designed to support things like life cycle. Documents need to be revised. Well, when you revise a document, how do you replace it so that the older one is deprecated and the newer one is obvious? So a discharge summary, some new information came in, I need to create a second version of a discharge summary. So we have a replace mechanism there for life cycle. The exchange bubble there is kind of showing the things about, how do I technically understand where is this document? How do I get it? What is its technical capabilities? Descriptive block is kind of the group of things that are around pure discoverability. It's type, its class, its time frame that it was used for, those kinds of things. Patient identity, obviously, in a patient-specific document sharing environment, patient identity is important. And in this case, one of the special things that we did in XDS is we preserved the patient's demographics as known at that time. So the source patient info is a record of how this patient was described at the time that the document was created. This helps people understand that things have changed, and more specifically, if you open up the document, since it hasn't been changed in 15 years, will call this patient this particular name. So you kind of need to know that you didn't get the wrong document, you got the right document. It's just that the patient was known differently then. Provenance, who created it, when was it created, those kinds of things. And then security and privacy. Who was the author? Are there sensitivity codes on it, confidentiality codes, those kinds of things. So getting a little bit deeper, and I'll probably go a little bit faster because these are deep topics. Within the XDS model, we have 3 different object types. There is a submission set. The submission set is there to explain to the registry, I am submitting these 3 things together. The registry then would tell everybody else, hey, by the way, these 3 things were submitted together. So that's a submission set. It's not all that important in many cases, but sometimes it's really important to know what was submitted together. Specifically when it's something like, well, okay, when I submitted it, I submitted this particular version of this lab result with this discharge summary, and oh, the lab result has revised since then. So you can see the differences, the change over time of what was submitted versus what is currently there. Folders are a more amorphous concept than a submission set. Folders can change over time. You can add to a folder, those kinds of things. A document entry is that metadata that I was primarily pointing at before, which is this is the document, this is its title, this is its description, this is its type code, its class code, its time frame. All of those things are the document entry. And then there are these associations. I talked about the concept of a replace. So a new document replaces a previous document. Before that, I talked about transform. So here is a FHIR document and a transform of it, which is a PDF. A different transform, which is a CDA. Appends, hey, this document now has an appendix. Signs, we have an object that says this is the digital signature across this set of documents. So we have these kinds of relationships between entries so that you can see these relationships. So how does MHD fit into this is kind of where I'm shifting gears. So I'll keep in mind, we'll continue to refer to the document sharing model, but I'm going to be shifting gears into MHD. MHD is mobile access to health documents. And right away, I'm going to speak to the word mobile. We, within IHE, needed some way to differentiate a solution that has a criteria to use FHIR from a more open-ended profile. So a more open-ended profile, we would look for the, quote, best standard available at the time. And this is not to say that health documents, if we started today, we wouldn't pick FHIR, but we already had XDS. So in this case, we had to say, well, we want access to XDS, but we want to use FHIR. At the time, we used the word mobile because the idea was mobile devices, whether they be phones or tablets or laptops or mobile units, they tend to have lower tech capabilities. They can't really support something like a SOAP stack. So, or they don't really do all that well with XML or SAML or the like. So we thought at the time that mobile would be a good way to say the client side has low technology capabilities. So when you see mobile with an IHE, it doesn't mean it can only be used with a mobile phone. It means it has a expectation of low capabilities on the client side. Does that mean you can't use it with a big iron? Absolutely not. So you can use MHD with a big server side client and a big server side server, and so it doesn't mean you can't use it. It just means that it has more limited capabilities, and therefore FHIR is picked. So in this case, since MHD was really just trying to say, hey, can we make it easier for these mobile devices to access XDS? We really focused only on how do we make an API out of FHIR for existing document sharing. So This is the diagram of XDS, right? So there's no MHD here yet. You've got your patient identity, you've got your document registry, you've got your repository, sources, and consumers. You saw that back on the graphic with the silos and such. So first I guess this is going to build rather ugly. So first on the consuming side, we say, well, if we add MHD consumer and an MHD responder, the responder could be grouped with an XDS consumer, and magically now these mobile clients can use FHIR in place of XDS. So this just replaces the XDS transactions with a FHIR-based transaction, thus making it easier to access XDS. And we do the same thing on the source side in case there is a need to have sources that would submit documents. Might not be as needed, but might as well go ahead and do it. And then we also said, well, you know what, the same model can support the cross-community access, which I really didn't describe, and I'm not going to go too deep into, but XCA is a way to federate multiple XDS communities or any other document sharing infrastructure. So XCAs tend to be these federations of communities. So with XCA, you can couple different enterprises. This is the diagram that XCA tends to put forward in that it's showing that there's multiple XDS communities or something else. So some of the big EHR vendors are themselves a participant here. So with XCA, we're really only dealing with the consumer side. So you have the MHD consumer again, talking to an MHD responder, and the responder is grouped with an XCA gateway. And from a pure modularity perspective, you can see how now all of a sudden you have FHIR access to any of those communities. So going back to this diagram here, the MHD is up here, being able to query into any of these. So you've got some FHIR accessibility to any of those communities, no matter what the technology is that they're using. So next up is, I've spoken to this a little bit. The whole XDS is reliant on things like patient identity, and we have PDQ V2 and V3 for patient demographics discovery, and we have a FHIR equivalent of that called PDQ-M. PDQ-M, on the right-hand side, you can see where the publication is. These are all on profiles.ihe.net. Search into the IT infrastructure area, and you'll see the supplements, the IGs there. PICS, Patient Identity Cross-Reference. We have a V2 and a V3 version. The FHIR equivalent is PICS-M. So again, you see the M is mobile, right? So I spoke to mobile. It doesn't mean you can't use it with big iron, but it has the distinction between PICS V2 and PICS V3 is FHIR with the M. In XDS, we use SAML, which we have profiled using XUA for cross-enterprise user authorization. In FHIR, we use OAuth. So IUA is the profile of OAuth for use within document sharing exchanges. IUA is very similar to Smart App Launch that HL7 has, and indeed they work together, but they also have some differences of the use cases. So if you want to use Smart, you can certainly use that. There's nothing in the infrastructure that says you can't. But IUA is more intended to cover the things like business-to-business communications. ATNA is audit, trail, and node authentication. It is our core security. It tends to use TLS, but there are other connection-based security models, including asynchronous security models, including things like SMIME for email. But ATNA also includes an audit logging mechanism that right now is standardized using DICOM as the standard. Well, within FHIR, we have basic audit log patterns, which uses the FHIR audit event. The FHIR audit event is harmonized with the DICOM specification. So the whole ATNA world is harmonized. So the FHIR equivalent, the audit event, is derived from and explicitly intended to be a semantic equivalent, even though that's syntactically FHIR instead of XML. And then we have document subscription models in XDS. Well, we now have a document subscription model in FHIR that uses the FHIR subscription, the backport in this case, so you can also subscribe to things. Another way to look at the comparison of XDS to FHIR is on the left-hand side is the XDS objects, document entry, submission set, folder associations, and the document bits itself. We talked about that. Over on the right is the FHIR resource. So document reference is equivalent to a document entry. So they are almost one-for-one equivalent. Document reference, because it's a FHIR object and it's been under standardization more recently, has some new capabilities that don't exist in XDS. MHD does restrict those things out because we want to have both directions ability. So we didn't want to have something happen in the MHD space that couldn't traverse through XDS and XCA and XDR and all those other models. So we do profile out some of those new capabilities in the FHIR document reference. For submission set and folders, we profiled the list resource. So there's two different kinds of lists. So it's not that we use the exact same profile. There's a profile of list that supports submission sets. There's a profile of list that supports folder. The associations, we use the document reference related element. So within document reference is already this associations concept. So you can say, hey, this document reference replaces this document reference, or this document reference is a transform of this. That relationships is built into FHIR document reference. So where W3C EB registry has an independent object called associations, in FHIR, we built it into document reference in kind of more of a RESTful model. And then the document bits over in XDS, which are just, a binary object. Over in FHIR, we use the binary resource on submission, but the beauty of FHIR binary resource is when someone goes to retrieve a binary resource, the client and server can use HTTP negotiate to unwrap the content. So if the binary is a CDA document and the client says, I'd prefer to receive CDA XML, the server can say, oh, well, let me rip off this FHIR binary and just give you CDA. So what comes across on the HTTP is pure CDA. It's not base64 encoded. It's not wrapped inside of a binary. It's just the CDA document. So there's some real advantages over in the FHIR space, especially because of some of the RESTful capabilities in this HTTP negotiate. It's possible with that same HTTP negotiate to say, a client could say, hey, I want a PDF version of this. And if the server wants to take a style sheet and run the content through a style sheet and produce a PDF, it is possible to do that. Will servers tend to do that? I don't know. That's going to be something that the market will have to show. So getting into MHD, so MHD itself, there is this transaction within IHE. We have numbers on our transactions. The IT Infrastructure Committee's number 65 is this provide document bundle transaction. That's the transaction name. It's effectively a publication request. So it's between a document source and a document recipient. It carries the concepts of a submission set. I'm providing these pieces of information, document references, binaries, maybe a list for a folder. Maybe I include the patient resource just because it's a push operation. And this is just one of the transactions, and you saw it on the left-hand side of some of the XDS and diagrams. So the document recipient would tend to be grouped with some kind of XDS document source, or it might be with the XDS infrastructure. But this also is a pure push concept. So for those who need to be able to just simply push from point A to point B some content, and there's no registry involved, this here is a RESTful push. Very simply, push, done. So this transaction can be used in a purely push environment. I just want to use HTTP RESTful to publish or push this information, or I want to publish it to a registry. And that what happens on the recipient side is a recipient architecture question. On the receiving side, or on the consuming side, we have a document consumer that asks the responder things like queries, queries for document references, queries for lists. This is just normal FHIR queries. There's nothing fancy here. There is a required set of parameters. There is a required to support set of parameters. So it is profiled. It's not purely, hey, go look at FHIR document reference. But effectively, there's not much specialization here at all. I actually, in the slide deck is missing some new capabilities on the publication side. We now have a capability, some new transactions for clients that don't want to spend time figuring out what a submission set is or what a list is. They just have a CDA document or a FHIR document, and they just want to publish it. So we have a transaction where the content is nothing more than a FHIR document or a CDA document. And the recipient of that transaction, it's a contract, will look through those structured content and derive the document reference and invent a submission set and do the right thing. So we have a lighter weight version of that. And then there's an intermediate. We have a transaction to just simply say, hey, would you look at this CDA document or this FHIR document and create me the document reference and give me back the document reference? That's kind of a case where you're going to ultimately use an ITI 65, but you'd prefer to not have to, you'd prefer to have some service extract out the document reference metadata. So there's those new capabilities. And then all right, so that's document sharing. I think I'm doing good here. So as I mentioned way back at the attributes of a document, that are really beneficial mostly to the source of the content. Receiving documents is not very optimal. If I am a document recipient, I have to pull multiple documents from potentially multiple servers and deduplicate. I need to change potentially some coding because, well, this source used one code system, this one used a different code system. So receiving documents, especially at a client end, is less than optimal. So we looked at that and said, well, you know what? I think we can work out something here as well. So we first created this query for existing data for mobile, and it essentially is a subset of the FHIR resources that are most clinically useful. It doesn't do much more than say that there are these clinically useful resources, and this is what a QEDM server would support. There isn't really any profiling of these. They're just the subset. So it says, hey, all the other resources within FHIR are not required. And in this way, the clients know that if they ask for these, they would potentially get them. There is a particular use case for this, and that is, hey, I want to make available to clients a QEDM query, which, by the way, I'll point out, QEDM, there's a new project within HL7 called IPA, so the International Patient Access. IPA is a more modern version of QEDM, but they're really intended to do the same thing. And indeed, I'm working to mold QEDM to be dominantly IPA based, but we kind of need to see some dust settlement before that actually happens. But effectively, if you have an IPA environment, you effectively have the same kind of concept as QEDM. IPA does profile the resources though, so there is that difference. So mobile, cross-enterprise, document data element extraction, MHDE, is this bridge between the document world and a QEDM world. So in this case, we say, hey, I want to, as a client, just retrieve observations and medications and immunizations. I don't want to deal with documents. So I want a service that's going to harvest all of the documents for this patient, deduplicate them, maybe upcode things, and make available the observations and immunizations and allergies through QEDM. So that's what MHDE does. And there are implementations of this. There have been open source projects of, things like CDA on FHIR that can bust apart a CDA into FHIR objects. The deduplication tends to be the real secret sauce. And the IHE profile doesn't tell you how to deduplicate or how to, it just says there is some functionality that is some vendor's responsibility to deduplicate in that. And then there's one other capability here. So within Blue are documents. This is the document exchange I've been talking about. You have medical summaries, episodes, discharge summaries, those kinds of things. These are independent documents. On the far right, you have some client that wants to use QEDM to receive observations and medications and allergies and immunizations. So you end up having this MHDE system that extracts out the various things from the documents. It says, oh, this is the exact same observation, so I'll call that just OBS1. This is the exact same medication, I'll call it medication 1. So it's creating this green environment, which is purely FHIR, which is QEDM or IPA. There's one additional thing that an MXDE server has to support, and that is it has to provide provenance resources that go from the FHIR resource back to the documents from which that particular observation or medication was found. So in this way, a client can say, give me the allergies. It gets 3 allergies. And it says, what? This second allergy I've never heard of before. Where is this second allergy documented? That's a provenance question. So you follow the provenance on allergy 2, and you see that that allergy 2 was found in document, 12 or what have you. And in this way, you can then see, oh, well, document 12 was a special case, blah, blah, blah. I don't know. So within the document, you can see the context, right? So when you're just looking at allergy 2 within FHIR, you don't necessarily know the context of allergy 2. But when you follow provenance to the document, you now have the context of the document. You can see what it was around. You can also see that this was only suspected allergy. It wasn't a confirmed allergy. And later documents don't include that, so there's been some kind of allergy harmonization for which allergy 2 has been, made less environment. So through this provenance linkage, you can find out for any of those resources what one or more documents did it come from, and then you can pull those documents and see the context. This is just really explaining the exact same thing, again, kind of showing that. So I think the only other topic I wanted to cover, and I think I'm really in good shape here, is that this is the thing I was talking about doing a read on a binary using HTTP negotiate. But this is the content I wanted to get to as well. Everything up until now always used XDS as the infrastructure. And XDS is a pretty dominant model today as an infrastructure, or XCA. But we have environments which are purely green fields. These are countries that don't have any health exchange today. They would prefer to deploy a FHIR solution and not deploy a SOAP XML SAML environment. So we created mobile health document sharing, MHDS, as a purely FHIR-based infrastructure. So the document registry, the document repository, the patient identity, the security model, and including things like directory and those kinds of things, we put them into this to say, hey, if you're in completely green fields, you could deploy a document sharing exchange using just FHIR. And indeed, this model you could do with one server, or you could kind of say, hey, we want one server for the registry, we want a different server for the repository and the patient identity. So you can have them as different, just simply because FHIR, has this beautiful ability to be able to separate those things out. But you could do it with exactly one server. So MHDS is everything that XDS is, except it doesn't use any EB registry, SOAP. It just uses FHIR. It just uses a FHIR server, an off-the-shelf FHIR server. There are some operations that we defined in things like MHD for being able to say, hey, here's a CDA document, you create the metadata. That's not going to be automatically supported by an off-the-shelf FHIR server, but you can kind of get the idea that if you're going to do the submission set bundle, that is supported by an off-the-shelf FHIR server. So the big advantage of MHDS is it's purely FHIR and OAuth. It's great for environments that don't have any XDS or XCA in that environment, in that way. So, conclusion of today, talked about XDS and XCA, talked about MHD as an API, but we also talked about MHD as a way to do just a push, or MHD as the thing that you use at the client side in MHDS. And then we talked about this MXDE and QEDM to make decomposed documents into resources with provenance. That is kind of the full topic that I covered. And I can take questions now.
Awesome stuff. Thank you, John. And let's open it up for brave people first. So I'll keep the recording on and we'll open it up for rest of the people later on if you want to ask something that's not recorded. Anssi, go ahead.
Yeah, thank you. That was very concise and informative, just 3 quarters. So thank you very much. So what comes to my mind is that this QED mobile, I guess that is also available on top of MHDS.
UED. MXDE?
Yeah, I mean, you went through this QEDM in the context of MHD. So
yeah,
that is expression of FHIR. So I guess this is available also on top of MHDS.
Sure. Yes. So an MHDS could have MXDE, to QEDM. In fact, is within the MHDS, we do discuss those things. So the amount of time I spent on MHDS is minuscule to the capabilities that MHDS provides. But absolutely. But again, you're going to have some kind of a MXDE service. That's not going to be an off-the-shelf FHIR server. That's going to consume the documents, decompose them, deduplicate, and make them available. But once it has done that, then those resources are in that FHIR server. So from that point forward, it's just normal FHIR. But yeah.
How about, if I may ask another question in a row? So how about, do we have real world experience from either MHD or MHDS or even QEDM? Do you know of any real life projects in production at the moment?
So I do not track particular deployments or product capabilities, but I do hear about them. MHD is, so there's totally different environments that are using these. So MHDS is being used in the new world because they don't have anything and it's easy to stand up a FHIR server. So that's where MHDS is predominantly taking off. There is some discussions within some of the Western worlds that have some regions that didn't do XDS yet, and they want to put in an MHDS because it's a lower impact. And I would absolutely support that. If you don't have something, then MHDS is there. So MHDS is predominantly in those green fields, those opportunities. I haven't heard of anybody wanting to rip and replace an XDS or an XCA environment with MHDS. QEDM is a special case, MXDE and QEDM. I know of products that do this. They just don't declare themselves as MXDE and QEDM. For example, within the US, one of the Health Gorilla is one of the new exchange participants. Health Gorilla is predominantly that. That is what they do. And that's cool. I wish that they would give, some props to IHE, but, they don't have to. I know of some of the typical healthcare intermediary vendors that also have that capability. So I'm a real fan of it because I think consuming documents is one reason why people don't follow that. I suspect that MHD over XDS and XCA is more common than I have visibility into, but I have no visibility into it. It is constantly tested at connectathons. So MHD gets the most testing at an IHE connectathon nowadays. So if they're bringing products to be tested, they're probably deploying them, but I can't be sure.
Well, as what I collected from this is that this has been implemented. I mean, so that we have the technical capabilities for implement this. But I understood that you are tracking if we have something in production somewhere,
right.
But you have not heard about any country or any health information exchange or anything where this MHD would be deployed in production. So you are not aware of any real world.
Yeah, but I don't know that I would. Yeah, I don't know that I would be aware. Yeah. I'm not in any position that kind of knowledge would ever come to me. Fact is, the people at the IHE Connectathon probably know better than me because they're working with the particular vendors. I don't even get to go to an IHE Connectathon, so I'm so much more upstream.
Thank you.
But yeah, it's very true. I don't know.
Thank you, Anssi. Great discussion. Any other questions? There's one in chat from Kari Heinonen. Have there been any talks how these IHE profiles relate to and work with EU eIDAS wallet apps? So in practice at the moment, that would be some pilot projects. Actually, just one called Potential working with EPED. So, John, are you aware of this eIDAS or EUDI wallet infrastructure? Maybe hard for you to answer then. It's kind of the digital identity framework that the European Union is setting up.
Yeah, I do not know, but the very fact that the standards we use are OAuth or SAML in the other case fits well within any kind of an identity system that uses standards. So, but I don't know.
And we have a separate webinar coming up about patient identity and so on. So you can check that for that webinar.
Okay.
I have a question as well. So in Finland, we have this centralized health information exchange called Kanta. So it is a centralized system. All EHRs are mandated to push data there. And that is based on HL7 FHIR medical records interfaces and also CDA. So mainly CDA documents. And now they are opening FHIR APIs for patient-facing apps into that system. What would be your recommendation? What FHIR profiles they should look into and consider in their specifications? There's one more week to give feedback, so the texts are currently out.
Well, when it comes to the topics I've covered, you can see from a publisher perspective, I think there's benefits to documents. And in FHIR, there are FHIR documents, and a dominant one that is specification that both you and I participate in is the IPS, the International Patient Summary. I think that has a lot of benefits to the publishers, to the consumers of them. The consumers could also use an MXDE, decomposing an IPS is easy. Deduplicating, if you carry identifiers, is easy. So I think IPS is the right place to start. Is it, rock solid at this point? No, but I think it is in good shape. And I think the publishing of documents has a benefit to the context discussion and the like. There isn't yet a good set of specifications around things like a discharge summary or an episode note in FHIR. But I don't think those will be very hard to put together once the need is there. And I think the FHIR model has some benefits. But quite literally, a CDA document is just as consumable at the technology level. It's just a little bit harder to wrap your head around, the differences in how things are encoded depending on the kind of data, which is kind of the unusual thing with CDA, where FHIR is everything is a resource.
Yeah.
So that would be my recommendation, and the exchange to be dominantly a document sharing exchange from the topic. I don't know that we have quite figured out how to have a federation of FHIR services such that you have the ability to traverse a federation, understand the results in context. So there are some discussions around that kind of an idea, but I think the problem is the environment is hard to put together at a RESTful level, whereas a document level, you can see the exchanges are pretty easy to put together. And there's some challenges to just being able to deal with RESTful across intermediaries and federations.
Great insights. Thanks for that. Building on that, I think the Kela, the maintainer of the Kanta system, they are first starting with the really minimum viable product, and that wouldn't be parsing the CDA documents into FHIR resources, rather just publishing the CDA within document references or in parallel to document references. I think their proposal currently is to package them as attachments to document reference resources. And I like how you've in the past explained that no, the document reference should be for the metadata, and then a client can query for the metadata and then ask for the actual content that they want to. And I think you referred to that one as well here with the HTTP content negotiation and so on.
Yep.
But can you just explain it one more time with your own words? Then we can refer to that as well in the feedback.
Yeah, and I see Carrie has clarified the EIDAS is the ability to carry your content on your mobile device. So there are a couple of different things in that space. From an IHE perspective, we have a well-established XDM. The M here is not the same as the FHIR mobile, but XDM is the ability to put everything into a zip file. So you have the metadata, you have your patient, you have the documents. So you still have all of the information around what is this document and where did it come from, what is its provenance. and it uses zip so that it compresses it well using standards. So XDM would be the relevant. I don't know if that's what they're using, but just given the definition of the use case, XDM would be the recommendation.
From my point of view, that's still controversial whether you would actually store any of your health data within the wallet. The wallet is more for verifiable credentials, and that might be a smart health card, for instance, that you store within the wallet, or smart health link that points to your data that lives somewhere else.
Yeah, the concept of smart health link, which is a developing concept, is potentially a good thing to do there. Unfortunately, the smart health link has this problem that you are storing the credential right there with the link, and anyone who gets a hold of that gets a hold of credential to pull your data whenever they want without restrictions or even auditing. So there's some discussion that has to happen with the smart health links before it really should see production use. But the concept is heading in the right direction.
Yeah. And of course, the way I've seen smart health links generated is that you can set, for instance, a password. You can set a time limit that link only works for this amount of hours, for instance. But I understand your point.
Yeah. The problem is the password goes with the link.
Yeah.
So you use the link, you've lost the password.
Sure. But then the time scoping the time might help in some cases, but it's not complete yet. I agree there.
Oh yeah. We'll get there.
Any further questions from the audience? We are 2 minutes over, so I think it's fine to close here.
Yep.
Many thanks, John. Looking forward to the next session. That is in end of August. Was it 26th? Somewhere around there. And again, Thursday afternoon, 3 p.m. Finnish. That's the Eastern European time, and something like 7 a.m. for John. So
yep.
Thanks for waking up for us.
Oh, no worry. Thank you very much.
I'll stop the recording.
All right. Bye.
Hey, thank you all.